Hello everyone, today I'll be showing you the basics of how to make player model mods for TF2. Here I will be replacing Scout's model with a custom model, in this case it's a Persian model. Here is what the result will look like. Bear in mind that this is my way of doing it, it's a bit time consuming. There might be better ways to do it, if so I'll make an update video in the future. Before making a model port, always check if you have permission to port the model from the model artist. Check if the artist has explicitly said that porting is allowed, or check the model's license. If you're using a model from a website like Sketchfab, always Google the name of the model and try to find the original artist behind it. There has been many cases of stolen models being uploaded there without the author's permission. Many parts of this tutorial were based on my own deductions while testing, so this might be helpful if this is your first time making a player model mod. Some parts of it have been taken from a Game Banana tutorial by the user AnklePain, and the link is in the description. First, open Blender and import the model of the TF2 class that you want to replace. To do that, you need to decompile the player model of your class, for example scout.mdl. You always want to import the SMD file that has morphslow in its file name, as it is the class's model. If the model has additional body groups that are essential to the shape of the model, for example Scout's feet, import those as well. Notice that after importing the files, you have a model and a skeleton. The skeleton is used to move the model. It is made of bones. Each bone can move a specific part of the model called a vertex group. A vertex group is a group of vertices. Here you can see, for example, if we select the bip_head vertex group, the head vertices will be selected in edit mode. A bone moves the vertices belonging to the vertex group with the same name. For example, the bone bip_upperarm_r will move the vertex group named bip_upperarm_r. Vertex groups have weights associated to them. Vertices with a high weight will move at the same extent as the bone, and those with a lower weight will move at a lesser extent. This is useful for fixing distortions around joints, for example the shoulders. It is possible to move bones and you can reassign vertex groups if necessary. Let's take a look at some of the vertex groups to get an idea of how things work. We have bip pelvis, spine 0, spine 1, spine 2, spine 3, neck, collars, which are the shoulders, arms, hands, fingers, etc. Now open a different Blender scene and import your custom model. Make sure your model has less than 25,000 vertices, as models with 25k or more refuse to compile with Crowbar. Anything around 20k vertices will compile fine. Bear in mind that I won't explain how to make level of detail variants in this video. Level of detail variants replace the model with a lower poly model when the player is far from it to improve performance. If your model has too many vertices, it will impact performance, some more than others, depending on the vertex count. What I do usually is that I try to move these bones a little bit just to be sure that the model is well rigged. If you do not notice any issues while moving the skeleton of your custom model, issues like clipping, badly limited regions, etc., you can proceed to the next step. Now what we want to do is to copy our custom model into the scene where the TF2 model is. First, you need to select your custom model skeleton, and then scale the skeleton so that the custom model matches the overall shape of the TF2 model. I usually use the shoulders and hips as a reference. So I make the custom model's shoulders overlap with the TF2 model shoulders. This is where you'll run into another issue, which is hitboxes. Depending on what you want, you need to be careful here. Do you want your player model to be hitbox accurate, or do you not care about it that much? This becomes a problem once you start scaling the model, because for example, the head hitbox might be smaller or bigger than your custom model's head. For this tutorial, I won't change the head scale because I want to preserve the original proportions of the model. Now move and rotate the bones of your custom skeleton to make the custom model match the shape of the TF2 model. You'll see that your custom model will look a bit distorted, but it's all fine as the end result will look much better in game. Once you manage to make your custom model overlap as good as you can and match the shape of the TF2 model, make sure to save your Blender project here. Now we'll deal with Vertex Groups. To create a Vertex Group, first select your model, then select the Data subsection, then click on the little plus icon, and now you have a Vertex Group. If you double click it, you can give it a name, for example, bip_pelvis. To assign vertices to a vertex group, select your model, switch to edit mode, and select the vertices you want to assign, for example, let's say this region. Once you've selected the vertices, you can click on assign, and now the vertices have been assigned to the vertex group. If you want to remove vertices from a vertex group, select the vertices you want to remove, then click on the remove icon. And now you can see the vertices are gone from the vertex group. If you want to make your custom model work in TF2, you'll need to create and assign every vertex group the same way that they're assigned in the TF2 model. For example, the bip_pelvis vertex group in Scout's model contains the vertices of the pelvic region and ends around the thighs, and it takes around 2 to 3 vertices above the waist. So for our custom model, we'll assign it the same way. Create a vertex group and name it bip_pelvis. Then select the vertices of the pelvis region and limit it around the thighs. Then select 2 to 3 vertices above the waist. Once you've finished selecting the vertices, assign it to the vertex group called bip_pelvis. Make sure that the weight is set to 1.0. And make sure to not leave any vertices unassigned. Every single vertex of the model needs to be assigned to a vertex group, and vertex groups can have shared vertices between them. Here I have assigned all the groups manually to showcase how it would look like. If you're assigning vertex groups and you have an issue with the base position of the model, you can do this. Switch to object mode, select your model, go to the armature modifier, apply it, select the skeleton of your custom model, switch to pose mode, go into pose, apply pose as rest pose, and then once you do that, you can select your model and then your model skeleton, Control P armature deform, and then select keep transform make parent. This way you won't have an issue with the pose of the model, and you will still keep the skeleton to work with later on if you need it. If you downloaded a model from the internet, you should already have vertex groups assigned. If you didn't notice any issues while moving the bones of your custom model when it comes to delimitations, you don't need to do much here, as we'll just rename the vertex groups to have the same names as the TF2 model's vertex groups later on, not now. If your custom model doesn't have a vertex group for a specific part of the body that the TF2 model has a vertex group for, you'll need to create a vertex group for it, then name and assign it the same way that the TF2 model does. An issue you might run into when it comes to downloaded models is that the spine might not be divided into 4 vertex groups like the TF2 models. For example, if your custom model only has 2 spine groups, you can rename the spine vertex group on the bottom to be bip spine 0 and the one on the top to be bip spine 2. But it's better to make the 4 spine groups manually the way I demonstrated earlier. Once you've finished assigning all the vertex groups, make sure to save your Blender project, as we're going to perform an irreversible change that can only be reverted by rolling back to the save you just made. The irreversible change here consists of applying the custom model's armature modifier. Then select your model and the TF2 model's skeleton. Press Ctrl P in object mode and select armature deform. Make sure to tick Keep Transformations. If you've assigned vertex groups manually, you should have all vertex groups assigned and finished. But if you downloaded a model from the internet, this is when you want to rename your vertex groups to be the same as the TF2 model's vertex groups. For example, rename the pelvis group to bip_pelvis, the shoulder group to bip_collar, etc. You need to rename the vertex groups of the custom model after you've applied the custom model's armature modifier, not before it. You can now delete the TF2 model. After you've finished working with vertex groups, we can now import a TF2 animation to make sure that our model is fully functional for TF2. But before we do that, make sure to save your project and give the save a descriptive file name like beforeanimations.blend. Now you need to decompile the TF2 animation file for your class. For Scout, it's scout_animations.mdl, and you can find it in tf2miscdir.vpk. Once you decompile it, you can now import animations as .smd files. I suggest importing the stand primary animation, as it is the one you see the most during gameplay. If you see vertices stretching to the center, this means that those vertices are not assigned to any vertex group, so you need to assign them to the corresponding vertex group. You might notice that parts of the model look weird and distorted, usually around the shoulders and arms. Here is where you want to fix the weights of the vertex groups. If you've assigned vertex groups manually, you will most likely see distortions here, as the weight was set to 1.0, which is the maximum value. Switch to weight painting mode. Select the blur tool and set the radius to be as big as the region you're working with, or bigger. Set the strength to 1. And then click multiple times on the center of the region until the model looks correct. Do this on every side of the distorted region until all the distortions go away. If this doesn't fix the distortions, you'll have to reassign the vertex groups, then use the blur tool to fix the weight painting. Now I'll mention a few things about textures. I won't go into how to make textures work in TF2 as I've already explained it in my weapon modding video that you can check on my channel. You'll find a timestamp for the texture part. The default textures of a custom model are always the red team variant. So the names of the texture here will be the names of the red team textures. I usually add red to the name of the texture to recognize it. Move your model to the Morph Slow collection. Select your model, then click on the scene icon. Then select SMD as an export format. Set the export path to be the folder where you decompiled your class model, and then click on export. And then click on the name of the SMD file. Here it's scout_morphs_low.smd. You should see this if the file has exported correctly. Open the .qc file of the decompiled TF2 model. You want to remove the LODs and the body group sections. Now go to the top of the text file and remove everything between the parentheses here. Now I'll explain a little thing about CD materials. These are the directories that the game will check for VMT files. The game always searches for the VMTs in the first CD materials path specified. If it doesn't find it, then it will search for it in the second CD materials path specified, etc, etc. Add a CD materials with the path VGUI replay thumbnails textures for your model to be casual compatible, and make sure it is in the first place. Make sure to keep the original paths as well, as they contain many assets that are essential for lighting effects. And now we'll need to edit the skin families. Skin families define what textures to render on which team and what state. For example, all the textures in the first entry are going to be rendered for the red team variant. The second entry has the textures for the blue team variant. Third is for red Uber, fourth is for blue Uber, etc. Something I forgot to mention in my weapon modding video is that the texture names written in Blender are the .vmt file names that the game will fetch, not the VTF files, as those are specified in the base texture parameter in the VMT file. Something important to point out is the following. If your custom model has 5 textures, then every skin family has to contain 5 textures, and I'll explain why. Let's write our red texture VMTs in. Then let's write our blue textures VMTs in. The game will approach the textures in this manner. The game will read the body red VMT and it will render the texture specified on the red team variant. It is the first VMT specified in the red skin family. So for the blue equivalent of that texture, it will read the first VMT specified in the blue skin family and render the texture specified. Here it's bodyblue.vmt. If you do not write the textures in that sequence, you'll end up rendering textures on wrong parts of the model. For example, rendering the head texture on the body. So we'll write our red texture names in the first entry. Here I have only one texture. then the blue, then the red Uber. You can write something in here like invuln red, for example. I'll show you how to make Uber textures and VMT files if you don't know how to make them. Then the blue Uber, same thing here, you can go with something like invuln blue, etc. I'll explain how to make Uber variants. Create a folder in custom for your mod. In that folder, create another folder and name it materials. Make sure that you've made the .vmt and .vtf texture files for your custom model and that you've placed them in the correct directory. In our case it was VGUI replay thumbnails textures. Now we need to compile our custom model using Crowbar. For QC input, select the decompiled scout QC file that you worked with earlier. And for output, select your mod folder in custom. Then click on compile. And now the model has compiled successfully. Now we'll test our model. Instead of launching TF2 and checking the model between modifications, we'll use a model viewer as it's faster and easier. You need to download HLMV++ and set it up. The download link is in the description. Once you have it set up, launch HLMV++ and import your custom model. So with HLMV you can do a lot of things to check if your model is correct and functional. You can go, for example, to the sequence section. This is where you're going to find all the animations of the class. For example, here we have the taunt animations. This slider lets you control the speed of the animation. If you set it to max, it's just going to be 1.0, which is 30 frames. If you want to make the animation slower, you just drag this slider down, and you can freeze it completely if you drag it to the end of it here. In the model section here, you can check your different skin families, and you can check if your skin families are correct. For example, skin number 1 is the red team variant, skin number 2 is the blue team variant, 3 and 4 are the Uber variants, but we still haven't assigned the texture to these, and I'll show you how to make them. For Uber variants, just make a 512 by 512 dark red texture in paint.net, for example, and a 512 by 512 dark blue texture for the blue variant. And then copy the TF2 Uber texture.vmt file, rename it according to what you typed in the Uber skin family. For me it's invuln red and invuln blue. And just change the base texture to point to the 512 by 512 texture you made, depending on which team the Uber variant is for. If you want to add light effects to the model, take the TF2 class texture VMT file, for example here scout_red.vmt that you can find in TF2 mesquider.vpk, and copy everything under the bump map onto your custom textures VMT file. Make sure to not include the bump map as it is specifically made for the class model and it does not match with custom models, unless you made a bump map yourself.